Hello, everyone. Welcome to the guest speaker event. So today's guest speaker is Dr. Kyle Cabasares. He works at NASA Ames Research Center, and um, he also graduated with a PhD from UCI, right? Yeah.
Yes, yes, yeah.
Yes, and with physics, doing physics.
Mhm.
And today he'll be speaking about his experiences about being Filipino American while also talking about his upbringing as a physicist. So, but other than that, I'll get to it. So, may everyone please welcome Dr. Kyle Cabesares, and I'll hand it off to him. So he'll start sharing his screen and talk about his slides. So,
All right, thank you. Just want to make sure. Can you see my screen? Okay. So, hello everyone. Like I already said, I'm Kyle Capasaris, and I'm excited to tell you about my journey in science. So, as the title implies, it has been a very non-linear path, but I've learned a lot, and I hope to impart some of that knowledge to you in this talk. Now, just as a disclaimer before I continue, I'm very much representing just myself in this talk, and I'm not representing NASA or the Bayer Institute in any sort of professional capacity. So, the talk will be kind of informal and personal because of that. So, let's just go ahead and continue here. The image here is to give you an idea of sort of my physical trajectory in life. Let me get my mouse over here. So I was born and raised in San Francisco, California. I then moved to the Central Valley in Merced to do a physics degree. I actually started my college career as a mechanical engineering major in my first year, and then I realized I just prefer doing pure physics a lot more. So I switched my major to physics and I picked up a minor in applied mathematics. And I then moved down to graduate school in Irvine, California, so in Southern California, not very far at all from Long Beach. And I had a couple of formative experiences when I was in Merced that led me to the conclusion that I should pursue graduate school. When I was in graduate school, I studied supermassive black holes at the centers of galaxies. That was what my dissertation was on. Unfortunately, I don't have time to get into detail about that, my dissertation work into this talk, but I can comment a little bit about it later on. And so after graduate school, I shifted course and decided to not stay in the university system. I thought I wanted to be a professor of physics one day, but then I changed my mind also, and then I moved back to the Bay Area to now where I am at the moment at the NASA Ames Research Center, working for the Bay Area Environmental Research Institute as a contracting data scientist. So that's kind of the big picture path that I've taken. And just to give you another idea of where I work, so this is the center. This is sort of an aerial view of NASA Ames. I'm currently actually in this building right now. It's known as the Sustainability Base. It was built only about 10 years ago, so it's actually one of the newer buildings at Ames. It's pretty environmentally friendly, has a couple of cool systems in it. This is just a picture of like the kitchen space that I have to walk through to get to my office every day. Funny enough, there is a vending machine. There's two vending machines here that are not shown in this picture that I just buy too much candy and snacks from every day. So probably pretend it's not there, like in this photo. So let me move on to the next slide. Oops, this way. Okay, so let's talk a little bit about my upbringing before I continue more about my job. I thought it might be helpful to just backtrack and give you an idea of what it was like to grow up in San Francisco for me and how I ended up picking science as a career. So on the left-hand side, you have me, my dad, my stepmom, my grandmother, my late grandfather, and my uncle. And then on the right-hand side, you have me, my mom, and my younger brother, Chad. So I would say that my upbringing was pretty non-traditional. I was the first in my family to be born in the United States. Both my parents and grandparents are from the Philippines. So my dad was is from Quezon City, and my mom was born in Bohol. My dad immigrated though to the United States when he was about 4 with his parents, and my mom didn't come over till she was about 28 or so when she met my dad. But my parents are divorced now, and they divorced when I was pretty young, so I was about 5 or so, so I don't really remember it that much. But during that time, I actually spent a lot of my childhood in different households. So uh, probably from like when I was born, so I was about 5, I was living with my mom and my dad while they were still together. Then I moved in with my grandparents from the ages of like 5 to 11 years old. And then I moved in with my dad, my stepmom, and my brother when I was 11. And then when I was uh, 13, so my brother is an individual who is on the autism spectrum disorder, and he does not have the ability to talk or communicate verbally. And so he lives in an assisted sort of home where people with special needs, have staff to help them go about their day-to-day lives. And so when he was 11 and I was 13, he moved to start living in one of those homes. And so then it was just me, my dad, and my stepmom living together at that point until I went off to college. So as you can imagine, it was a fairly, kind of chaotic upbringing in San Francisco. Just, really having one specific place I stayed for any length of period of time. But, very grateful for what my family has been able to provide for me. I mean, they always encouraged me to do what I was interested in. I was never really pushed in any one direction. To be honest, I was kind of just left to, go to school and find what I found interesting. And I had their support with almost pretty much anything that I wanted to do. But to be honest, the things that I wanted to do, I think in their mind was very practical. So I guess they were fine with it. Um, One thing I will say though is that my brother is definitely one of my biggest influences in my life. I still see him every week or so with my dad and my stepmom. We usually go out to lunch with him. And so we maintain a pretty close relationship despite the differences and the difficulties with communication. But I'd say actually he's really taught me how to communicate well and get along with people who are just very different. And I think that's been one of my greatest advantages actually in life, being able to communicate with people from all walks of life and not feel too strange about doing so. So, okay, moving on. Let's go to how exactly I found, my passion of doing science and science communication. Well, I'd say that for most of my early life, I really had zero desire to be a scientist or have anything to do with that involved math. I almost failed my first high school geometry class, and I remember when I barely passed it, I said to myself I would never do anything that involves math or science as a career, which is very funny looking back now, but I truly felt that way at the time. But what changed was when I was 16, I was a junior in high school, and I had two really influential teachers, both my math and my physics teacher at the time. And these two teachers were just great. I mean, they really made their subjects understandable. I really finally felt I understood math for the first time in my life. Like before, it just really made no sense. It was just a bunch of weird symbols and letters and stuff. I forgot when exactly the transition from numbers to letters happened, but I somehow got lost in all of that. I was pretty good at doing arithmetic, but then once the letters came in with like X and Y and stuff, it was a mess. It was a disaster. But these teachers really helped me. They obviously inspired me to pursue science and math in college. I also read this book, A Brief History of Time, by Stephen Hawking, who passed away in 2018. But he was definitely one of my biggest inspirations after I read this book. And so after I read this book and I started getting into physics and math, my first quote unquote dream job was to be a high school physics teacher. And then that evolved into a university physics professor. And then after that, it's now changed to just this very generic person who tries to make the world safer and smarter, which I don't know. I feel like it's broad enough that I can feel like I can do that in several different roles that are not just limited to these kinds of roles because, well, as you'll find out in this talk, I don't like limiting myself to just a few options. Okay, so let's try and summarize the journey from student to professional, but that's a bit difficult to summarize about 10 years of experiences on one slide, but I'm going to try and do it some justice. Probably going to miss some things. Now, I'll emphasize this more in my talk, but there were really three key experiences from the years of about 2015 to 2023. So that's for me, that was my sophomore year of college to the end of graduate school. And those three experiences were one, an REU, or also known as a research experience for undergraduates, which I did at my undergrad institution. That was in between my second and third year of college. That was in the summer. So then I did a NASA internship between my third and fourth year of college, the year after that. And then the next formative experience was I'll just put graduate school very generically, those 6 years. It's kind of hard to encapsulate 6 years in just one slide or 10 years, but yeah, those are probably the biggest things I'd say that helped, bring me to where I am today. And so here's a bunch of different pictures here just to briefly go through. My REU, my research experience for undergraduates, was funded by the Lewis Stokes, so it's LSAMP. So it's Lewis Stokes Alliance for Minority Participation. There's also one specifically for California, which is called CAMP. And I believe the CSU system also has LSAMP at their campuses. So I'd highly recommend people who are interested in getting to internships or research experiences to really look into CSU LSAMP or just LSAMP in general. And when I was uh, doing this research experience, I was studying these things known as liquid crystals. I won't get into the science of it and all, but this is like me presenting um, my poster from that experience. Actually, at UC Irvine, this was actually the very first time I went to UC Irvine. I had no idea I would actually end up going to graduate school at this point, but that was kind of interesting. And then for the year after that, I went to do this internship known as the NASA Student Airborne Research Program that we got to fly on this plane known as the DC-8, where it's like a 747, or maybe not quite a 747, that has like a lot of the seats taken out and it's replaced with a bunch of scientific equipment and sensors, and it's mostly used to study atmospheric properties and the chemistry that happens in the atmosphere. It was really cool, though a lot of us got really sick because the plane kind of goes up and down, kind of like a roller coaster. And so, yeah, it was a really cool experience, but made me really dizzy. And then, of course, the last thing was graduate school, which this is me getting hooded by my advisor. That's just when you graduate, you get this sort of hood put over you to commemorate that you're a doctor now. And you get to wear this like 13th century or 14th century, robe-like thing. So kind of cool, though kind of expensive for just wearing it one time, but whatever. It's just part of the ritual. Okay, so I'll talk briefly about my job, and this, like my talk suggests, this talk is kind of nonlinear, just like my career path, but hopefully you can bear with me. But yeah, I'll talk briefly about my job to give you some idea of what I do. I'm part of this group known as the NASA Earth Exchange, and we are a group that focuses on combining supercomputing with big Earth science data sets. Our team is made up of several different kinds of scientists. You have like remote sensing scientists who use satellites and sensors like radar or sonar or LiDAR to measure properties of the Earth. You have like oceanographers, obviously, who study the ocean. You have data science and machine learning specialists, ecologists, ex-astrophysicists. That's me. I'm the only ex-astrophysicist on the team. But we are a very diverse team of scientists, and I think it's just really cool what we do. And to give you an idea of what my life looks like as a data scientist, this is actually a funny AI-generated rendition of my desk. I don't want to show my actual desk for security purposes, but this is basically what my desk looks like every day. It's usually just three screens, my work computer, and then my two external monitors, and me
No, no, not be using.
standing in front of it's me just usually standing in front of this. It's a standing desk too, which is kind of nice. So that's what I basically see most of my days. But I'm doing a lot of Python programming. I'm submitting what are known as computing jobs to the supercomputing facility. That's where you just write like a computer program that you don't want to run on your actual laptop, but you want to run it on some powerful machine that's on the center. And so you send a request to them saying, hey, I have this script that I want to run. Please execute it on your really powerful machine with all those GPUs or whatever. And when I'm not doing the programming, I'm usually meeting with other scientists or I'm reading scientific papers. And that's, I'd say, basically what my job is like. Usually looking at these three screens, we're talking to people or talking to the interns that are here, maybe giving them some advice, things of that kind of nature. But I like it. I know it may seem a little bit boring, but I really enjoy it. This is actually quite funny because when I was in graduate school, I had a very, very similar setup to what I have here at work in terms of this is the same kind of computer, I'm using the same programming language. Didn't do any supercomputing in grad school, but nevertheless, I found it kind of amusing when I started this job that there was actually a lot of things in common with my experience as a graduate student. And let me move to the next slide. I can. Okay. So part of the job also is getting to travel to conferences. So this is me presenting a poster at the American Geophysical Union meeting about 4 months ago in Washington, D.C. So it's the biggest conference for geophysical scientists or the earth scientists in America, and people from all across the world come to attend. And so this is me presenting the poster showing the work that I had been doing at NASA at the time. Also thought it'd be cool to wear a nice traditional Filipino barong there, just to represent and highlight Filipino heritage. And so I'd say that conferences are definitely one of the most enjoyable parts of being a scientist. You often will find yourself going to at least one or maybe two conferences a year, or if you're like a superstar in science, you get invited to like half a dozen to a dozen because you're that great and people want to hear you talk. Um, but it's basically a place where you share what you're doing. You get to meet people whose papers you read all the time, but you never met in person. And it's a great place to establish collaborations and find future people that you might want to work with and write proposals with. And the scientific community nowadays, it's so international and spread out. Like, NASA has so many different partners across the university system in America, and even not just America, but the world and the private sector. And so, yeah, science is really, really international these days. And so even if you work at one place like NASA or I don't know, another institution, you'll often find yourself working with people across other institutions, other states, other countries even. And I think that's just really cool, especially when you get to meet up with them at conferences like these. Okay, next slide. Ah, yes. So a little bit more about what the poster had on it. So the work that I do involves this technology known as LiDAR. Now, can I just get a quick show of hands? Have people heard of what LiDAR is? Some people do. Have people heard of radar and sonar? People have heard of radar and sonar. Okay, good. So radar and sonar and LiDAR all are kind of in the same class of family. It's basically using some signal to reflect off something else to tell you how far something is. So in this case, LiDAR, it's usually a visible or an infrared laser mounted. In this case, the data I work with is on a plane, but it can be also mounted on like a truck or sometimes even just handheld, right? If you've ever seen like a Waymo a car, those cars that kind of have like those spinning things on top of them, that's a LiDAR that's basically scanning its terrain like every second to make sure it's not going to, hit something. So anyways, LiDAR, just like the name suggests, it stands for light imaging and ranging, I think. See, I had this ready. What does it say here? It is, yes, light detection and ranging. Sorry, light detection and ranging is the acronym for LiDAR. And as the name suggests, you have a laser pulse that just gets shot down, and then it hits some object, and then it reflects back to the plane. And then based on how far or how much time it took for the laser pulse to get down to the object and back, you can measure really precisely how high that object is off the ground, for example. And so what you get is a nice three-dimensional representation of the surface that the laser beams hit. And so this is known as a point cloud. Point because you get the sort of the XYZ positions of all those laser pulse returns coming back to the sensor. And so you can map out in detail the terrain of the Earth or trees or buildings. And I just think it's a really cool technology in terms of what you can see with it. So what I've been doing a lot at NASA is been creating kind of this sort of pipeline that takes in these point clouds and funnels them to the NASA supercomputer known as Pleiades, and then processing them through sort of these two different routines that I've written in Python that actually this one's in Python, this one's in R, and it creates a bunch of other products that are much more easy to interpret and work with because these point clouds are they're very large in terms of their data size. Like they can be these over like a whole county, for example, in California, we could be talking about a couple terabytes of LiDAR data. And so getting this data into a format that's easy to read with the information that is needed for whatever application is important. And so this is kind of what my processing pipeline is trying to do, sort of take in data like this and then spit out a bunch of interesting statistics or other kind of metrics that different kinds of scientists are interested in. So let's just look at some applications. So one application here is this is a 60 centimeter resolution height above ground map that covers basically the entirety of Santa Clara County in Northern California. So this is like the city of San Jose. NASA Ames is kind of like around here. And what this map is you have to think, okay, if you take a 60 centimeter box or square on a side, 60 centimeters is about 2 feet. So you have to imagine about, a 2 foot by 2 foot box covering the entire county, that for every 2 foot by 2 foot box that covers this entire county, you can get a measurement of the height within that box. And so this is really, really high resolution data. You can see here you have like the Diablo mountain range over here on the east side of San Jose. And on the west, you have the Santa Cruz Mountains with these really tall redwood trees. So red is like really tall, right? Like 40 meters. So that's something like over 100 feet, whereas dark blue is closer to the ground. And so you can imagine when you zoom in, you get these really, really nice detailed maps of how tall buildings are, how tall trees are, and the applications are numerous, from forestry management or flood risk management or urban planning management. There's a lot of management going on here, but there's a lot of different applications. We didn't design our pipeline with any specific one application in mind. It was mostly trying to cast as wide a net as possible to generate products that people in different fields of science or business even can find useful. So that's one application. Another one, this is, again, a sort of a height above ground map of this area in Northern California that was devastated by a fire in 2017. And so we had two different LiDAR acquisitions, one pre-fire in 2013 and one post-fire in 2018. And so you can look at the LiDAR data, you can create this height above ground map, and then you can take a difference between the two and just see, where are the areas in this region that have just been most disrupted by the fire, where the vegetation has burned down a lot of that, those trees. One last application that I'm going to show is this is, again, another height above ground map where you have this transmission line that's in red here, or it's just really tall. That's why it's red. That's you can clearly see it's mapped out in the LiDAR, but you can also see that it's really close to these tall trees and vegetation. And you can do a simple analysis of just looking at every pixel, in this sort of set of trees here and measuring how close it is to the wire. And there are regulations in California, different counties have different regulations, but you can check to see if these trees are, up to code and are not technically in sort of these hazardous zones where they shouldn't be, and if they're violating the height requirements. So hopefully I don't have to convince people in California that trying to prevent situations like these where wild transmission lines can cause fires, hopefully that's a good use of the data, because I think if all of us are from California, I don't know if that's true, but for any of us in California, we know, how devastating wildfires can be. Okay, so now that you've seen a little bit of what I do in terms of work, I'll talk about just sort of the demands of the job. And it's kind of hard to quantify exactly, because in some ways it's not completely dissimilar to what I experienced in graduate school. Roles in scientific research, whether you're a grad student or a research scientist, seems to have a lot of things in common. That usually involves literature paper or book reading, weekly meetings with your team and your direct supervisor, seminars with guest speakers, kind of like this. And then also just feeling confused a lot of the time as you figure out how to solve problems that come up in your work. And I'd say that one thing that I've tried to do more at my job that separates my time from college and graduate school is to set better boundaries and practice better time management. So since I was an undergraduate researcher and all the way up to now, I've never really had kind of like a micromanager watching my every move every single day. It's mostly been just group and weekly meetups. So sorry, weekly meetups with both my group and my direct supervisors, where I share my progress with my research and work. And that's where you kind of discuss any sort of bottlenecks in the project, tasks that got to be prioritized, and things of that nature. And so because the meetings are fairly infrequent and I don't have, again, someone just watching me every day, I've had to become fairly self-reliant and self-motivated to get the work done in a timely manner and not just procrastinate too hard and put it all to the last minute, which, maybe sometimes I still do, but, maybe not. Um, let's talk a little bit about why would someone want to work at either the Bay Area Environmental Research Institute or NASA. And this is hard to say, but I would join. Well, I mean, I kind of have, but if I had the following qualities, I would strongly consider joining either of these organizations. One thing is that you're not in it for the money, flatly put. Working for the government or a nonprofit like Barry are just simply not as lucrative as the private sector. Very few people choose to do science for monetary reasons. Engineering, maybe, but science, there are several other lucrative careers you could do if you have the grit and determination to be a scientist. And if doing science doesn't make you happy, then you're probably going to be better off doing something uh, else. Um, I'd say if you are a person who wants to help make the world safer and smarter, which is just my motto, you'd probably find our organization is a great place to work at. And also, everyone here from whom I've met so far in the 18 months that I've been here is just really kind and brilliant and really understanding of, life situations that come up that may disrupt your ability to focus on the work. So I'm really grateful for that. And let's move on here. The next two slides are just some thoughts I've had since I started working that compares and contrasts what working a job is like versus going to school. So, from my experience, there's really little quote unquote classroom knowledge you use at work. For example, I'm not solving integrals or differential equations or doing matrix multiplication by hand every day at work. I don't have to remember what the speed of light is or how massive the Earth is in kilograms. I mean, that's just all stuff you can look up in an instant. But I'd say that school helps you get the job because performing well in school demonstrates to employers that you can meet the standards of a curriculum well. But at the same time, your exam score, your GPA really says nothing about your character, how you make decisions under a tight deadline, or how to collaborate with others. And so a lot of those kinds of skills, I'll talk about that in the next slide as well, you kind of just have to learn elsewhere or on your own. So on the next slide here, again, I'll say that the classes are important, but they're definitely not everything. The skills that I think translate really well from college or graduate school to a career are the problem solving, the critical thinking, technical. You kind of need to have that sort of baseline technical knowledge um, and skills like self-teaching and self-learning in the sense that I don't know about you, but when I was in college, I definitely didn't learn everything I learned. I didn't learn everything in a class just from the professor. I had to do a lot of, learning outside of the classroom as well. So uh, those kinds of skills are important. But outside of the classroom, things that I've had to work on are like communicating with people with different, backgrounds than me in terms of not even just like, ethnic backgrounds, but just technical backgrounds. If someone is not a scientist, how do you communicate with a larger team than just maybe one or two or three people? Like my team at Ames is like a dozen people, so that's a lot of different people to talk to. How to be a professional, just how do you write a nice email? How do you request to network with somebody in a professional way? Um, and also the skills I'd say that are most important for a given job is usually learned on the job. And that often just can't come elsewhere except when you're at the job. So I would say that don't feel that like you need to take your entire textbook to go to a job. That's not the way that you're going to succeed. It's mostly just being able to learn quickly and not wasting too much time and finding the answers on your own or going to the people who have the answers or can help you find the answers and knowing how to talk to them. Okay, so I'd say the key again to developing some of these skills. And one of the more formative experiences in my life have been the internships. So I talked about the REU experience I had at UC Merced through the camp program. Without this program, I would not have ever considered going to graduate school and getting a PhD in physics. So that obviously had a big, profound influence in my life. And really happy I did do it because it was in this field of experimental physics slash material science, looking through microscopes, working with these ovens and this stupid machine that never actually worked when I needed it to work. Um, but I never thought I'd be an experimentalist, and I didn't end up going to grad school doing this kind of work, but I'm happy I did it for 2 years. It really brought me out of my comfort zone. I learned a lot and got some hands-on experience with what it felt like to be a scientist. And then my second internship again was the NASA Student Airborne Research Program, and both from both of these programs, some of my closest friends I met through these programs, and I'm still friends with today. A lot of people from my class here in the NASA Student Airborne Research Program also now work at different NASA centers, and so I often get to see a good portion of them when I go to a conference. Like when I was at the AGU in Washington D.C. 4 months ago, I had dinner with several of them, and we just got to catch up and talk about how we're doing. So, and I'd also say this second internship is pretty much the reason why I have my current job right now, because when I was looking for a job, I saw that my organization right now, Barry, is hiring. And so Barry actually runs this internship program now that it transferred ownership a few years ago after I ended, but now they run the START program. And so because of that and because of my connection, I networked with my old internship manager and just said, hey, I know you don't work at Barry anymore, but they're hiring. Could you put me in contact with, someone who you might know is hiring? And so that one thing led to another, one email got forwarded to another email, and eventually I got to talk to the person who is now currently my boss. So really powerful that this internship, even 8 years later or 7 years later, was able to help me get my current job. So the professional and personal connections you make during internships can literally help you get a job, but you do have to be willing to do the seemingly scary thing of reaching out to people and ask for their help. And so also, I can't understate the importance of the school clubs in my development as well. So I was mostly part of two clubs in college. It was the Filipino American Alliance or PAA, what we called it at UC Merced, and the Society of Physics Students. So when I was in PAA, I was actually part of the choir, which is, again, one of those scary things I never thought I'd actually do. But here I am singing the Filipino and American National Anthem back in 2014. This is on YouTube, by the way, if people can find it. It's pretty interesting. We sound pretty good, I have to say. We practiced a lot. And I thought it was a really good experience of, again, getting out of my comfort zone and making more friends, learning how to work as part of a team or a large cohesive singing unit. And on the right, this is a picture from our SPS club in UC Merced, which we actually got recognized as like a, I don't know, I forgot what the exact award was, but it was like an outstanding chapter award or something from the headquarters of SPS. And so I was an officer in SPS, and a lot of my friends were as well. And we would hold review and study sessions when doing these really hard problem sets you have when you're a physics major. And again, like my internships, I'm still friends with some people in these clubs to this day. Okay. And lastly, I'll end. I know I've been going on a while with some pieces of advice that I wish I had when I was in college, and I'll try not to belabor each of them too long. But first one I would say is definitely go to your professor's office hours. If you are interested in doing an internship or going to graduate school or med school, you're going to need to have letters of recommendation from professors who can speak to your ability to perform well. And so it pays to go to your professor's office hours. And especially when I was in undergrad, I went to a really small school. And so getting, uh, more one-on-one time with these professors, I thought was really important. And, getting the support I needed to go to grad school and these internships. Also, when you're in university, you get access to a lot of free stuff. Like I can't even like remember all right, I can't believe how many things you can get for free when you are a university student and you have a valid university email. Take advantage of this stuff, really. I mean, I miss a lot of these things. I miss getting like free journal subscriptions and you know, not having to pay for some of the stuff you can get as a university student. So while you still have it, make use of it. Um, Third thing I'd say is to, like I've talked about before in this talk, to aggressively pursue new learning opportunities outside the classroom. I think now more than ever, doing things outside the classroom will pay dividends in the sense that a lot of knowledge, right, can be found both in the classroom and outside the classroom, whether it be online or AI. I know AI hadn't come up yet, but so I think being able to demonstrate you have real skills in whatever you're interested in doing in a real sort of professional context is super important. My fourth thing is to go either to school or to intern or to work where you're wanted. When I went to college, I only had technically there was two schools that accepted me, but I didn't get to the school I really wanted to go to. I only got into one, but UC Merced also let me in. I didn't apply to UC Merced though, so that was the interesting thing. So I always say technically I only got into one school for college. Also for grad school, I only got into one graduate program, and also for my job, I only got into one job. So maybe, I didn't have a ton of choice there, but I guess this point could have also been make the most of the opportunities you're actually given because, nothing is guaranteed. So when you do get an opportunity, work really hard and make the most of it. Five, I'd say get out of your comfort zone and to not what I call fake fear holding you back. Um, and what I mean by fake fear is like I kind of differentiate between two kinds of fears. There's sort of fake fear and then there's real fear. Real fear is the kinds of fear of like mortal fear of like, my life might be ending because of something really badly, like seriously. But fake fear is more like, oh, I'm afraid to, I don't know, talk to this professor and ask them for a letter of rec, or I'm afraid to send this email to network with somebody, or I'm worried how someone is going to perceive my major change in college if I might really want to do this major, but I'm not so sure, my friend or my relative is going to really like that I changed my major or something like that. That's what I would kind of consider fake fear. And so when you don't let that hold you back, you can do almost anything, I think. And six is this quote from Bruce Lee that I really like. It's called "Be like water," and that's just to be very adaptable in any sort of situation you're in. Water takes the shape of its container, right? And so whenever you're put into a new situation, it's just saying, try and be as flexible and adaptable to your situations as possible, because oftentimes you'll be put into situations where you just have to adapt, like working at a new place for the first time and not knowing anything, like me. Seven, oops, sorry. Seven, let me go back. Oops, not yet. Seven, if you're considering graduate school, I would say really ask yourself, do I want to do this? Because graduate school, especially if you do a PhD, is not just 5 or 6 more years of undergraduate. It is a completely different beast altogether. You do take classes the first year or two, but then it just becomes this sort of research grind. And if you really don't like research, then going to graduate school just because you don't really know what you want to do after college is a really bad idea, in my opinion. Some people can do it, but I don't think a lot of people can. So really ask if you really do you really need to go to graduate school in the sense of does the job you really want to have require you to have this degree? Because when I think about it, like for example, in my case, I'm really happy I went to graduate school and I got my degrees in physics, both my master's and my PhD, but that was because I thought I wanted to be a university physics professor at the time. When that changed and I switched sort of my idea of what I wanted to do, the job I currently have right now, you don't need a physics PhD to do it, right? There was probably a much easier way for me to get this job than going the physics PhD route. But like I said, I've taken a very non-linear path, which I think segues well into the last point. And it's that the non-linear path is definitely more unpredictable, but it's a lot more fun, which is why I always say if you get that fork in the road, take the one that's more non-linear. But that's That's just me. So, anyways, thank you again for listening. You can connect with me on social media anytime. I'm most active on my YouTube channel. You can also see if you're interested about the black holes and you're sad I didn't get to talk about it. I do have my whole dissertation talk. That's about an hour and a half, which summarizes 6 years of work in 90 minutes. So if you have 90 minutes to kill, uh, feel free to watch that. Um, and with that, I'll thank you for listening, and I'll take any questions you may have. So thank you again.
All right. Thank you, Dr. Kyle. So now I'll open it up to everyone else. So if you guys have any questions to Dr. Kyle, you guys can start asking them right now.
This may not be like the most relevant, but I know you read Stephen Hawking's book. I was
Mhm.
wondering if you've watched The Theory of Everything and like
Mhm.
if you had any opinions on that movie.
Oh, yes, I've seen that movie multiple times. I think it's a really good movie. There are some slight inaccuracies that don't really change the movie structure that much. There are just a few scientific inaccuracies, not even scientific, but there are just some like sort of factual inaccuracies with it. And um, I get into arguments with one of my good friends a lot because he's mad that that movie won Best Picture. Or no, he's mad that who is it? Eddie Redmayne won Best Actor that year over the guy who came in second, or another actor. But I really like that movie. I don't have any issues with it. It's kind of sad. It's really touching, I think.
Cool, thank you.
Yeah.
Hi, yeah, and I can we met before, but I can segue in with any with a more targeted questions. So feel free to interrupt uh me if you guys have any questions, but I have a couple that we decided that were pretty general and I guess useful. Um, sorry.
No worries.
Okay. So, one question I guess from the start is, how do you think that your education affected the rest of your career?
Hmm. How do I think my education affected the rest of my career? I mean, it was absolutely necessary. I definitely don't think I could be doing what I'm doing now without at least doing my undergraduate degree in physics and those internships. I think that from a more, I don't know what even kind of perspective, but from a different perspective, I think going to graduate school really changed my opinion of what I thought university life would be like from like a professor's point of view and what their role is and what their job is like. And after seeing, you know, or being around professors and working amongst professors for 6 years, it just convinced me more and more that I do not want to have their job, which I thought was really uh, uh, important because that's what I thought I wanted to do, right? Um, if you want me to elaborate more about what they do, I can say about that. But yeah, that's it. It convinced me to not continue on the path I thought I wanted.
Okay. Moving along down, I guess the question list. Anybody else have anything right now? Okay. Um, so how have you felt? Have you ever felt that your identity,
Hmm.
um, any type of identity that you kind of align yourself with, has that have you felt impacted by that in any of the institutions where you've been, where you've worked?
Yeah, so this is a good question. You know, I would say that I'm fortunate enough that I've never really experienced, I'd say, overt discrimination or racism per se. I would say that there have been multiple occasions in either college or grad school where I think people were just generally surprised that I was a Filipino in physics. Not to say there aren't us who do it. I can tell you quite a few of others of us. But I think there were just a couple of times where I remember someone saying, "Oh, you don't really look like a physics major," or "You don't really look like someone who would be studying physics or have a physics PhD." And I'd be like, "Oh, what do you mean?" And so, but I've never, like, again, I think that's mostly the worst I've ever received, which I think is pretty tame, honestly.
Uh, I guess others other than other than a physics professor, were there any other types of jobs that you kind of had growing up, I guess, at any stage, and how does it align with your current interests?
Yeah. So did I have any other jobs that I kind of wanted to do when I was younger? Before I got decent at math and physics, my favorite subject was history, actually. And so I had this idea in my mind when I was 15 that I wanted to be kind of like a scientific historian. Um, and I still do really like history to this day, so I do kind of just study it as like a hobby. Um, but I think that the the history aspect of science I find to be very compelling, and actually I've made a few videos about it on my YouTube channel, and so I think I've been able to kind of integrate those past interests not into a full-on career, but more as like a hobby these days.
Uh, okay. Kind of deviating from questions, I guess more specifically to your research that you did during your PhD. How how would you describe the astronomical scales that the mass of a black hole reaches, and how do you make sense of it? What do you look for?
Yeah, that's a good question in terms of how do you actually comprehend all that's happening. I was at a seminar kind of like this where we were on a call and we were discussing the latest discoveries in astrophysics. I still occasionally, um, even though I don't get paid to do astrophysics anymore, I still stay in contact with people in the field. And so at Ames, there's an astrophysics branch of researchers, and I attend their meetings sometimes. And so today we were talking about some, bizarre discovery. And I was just saying, isn't it just so weird to think that there's this telescope, the James Webb telescope, it's floating out, a million miles away from Earth, looking at something that's trillions of miles away with light that's traveled billions of years to get to it. We can somehow look at it. Specifically to the black hole question, I think honestly, how I make sense of it all is really through the math. Like, I don't really think there's much physical relevance or even it's worth even trying to imagine like a physical scale. I mean, the sun, these black holes are millions to billions of times the sun. The sun is like a million times the size of the earth, or a million times the mass of the earth. Um, and so, and the earth is much bigger than me as a person. So it's just, yeah, I don't really, I think if I tried to think about it at that detail every day, it would honestly kind of maybe slow down the process of actually doing the science. And I think at some point you kind of just develop these um, you just get if you do it enough and you make it just sound so casual that it doesn't sound as mind-bogglingly huge, then you can work through it, I guess.
Okay. I actually have so I'm aware that a couple people in here have seen your YouTube channel. So,
Okay.
um, if you guys have any questions, about any of like his YouTube videos, you guys can go ahead. And also I'm aware that there's some people in here that are interested in data science. So if you guys have any data science questions specifically, you guys can go ahead. Um, but yeah, and hold on, give me a moment.
Okay.
Oh yeah. So Josh Alba asked, how does research vary between undergrad, grad school, and at work?
Okay, this is a good question. How does it change amongst the three environments? I would say that undergrad, you're given like the biggest leash to just explore, and it's okay if you mess up. Like I almost broke the microscope that's like $30,000 in our lab space on one occasion. Um, don't try and break things. It's not a good idea to break things. But I think as especially when you're an undergrad, the expectations are pretty on, I'd say, on the low side, no offense. It's just that your fundamental knowledge hasn't fully been developed yet. And so you're not expected to know kind of everything as an undergrad. Though when you get to the graduate level, when you're and things change actually too as you get to go through grad school in the sense that when you're new and you're just starting out, it's kind of like undergrad in the sense that you're given kind of this leash to kind of just mess up and figure things out. But eventually you are expected to figure it out and become a competent professional, because the whole point of graduate school is to build you up into being, at least for the sciences, is to build you into being a professional scientist. So you're trying to, get to being someone who can you can do independent research. And I'd say by the time you get to, a full-on job, if you've gone through the rigors of graduate school and you have your PhD, the worst I think is mostly over, honestly. If you can get past, I'd say like that year one, between year one and year three of graduate school, where you're probably the most like ignorant of everything you're ever going to be in your subject, um, then you're in good shape, I think. Yeah, you can survive that.
Does anyone have any more questions or anything? Uh, okay. Oh,
I
wait, Josh,
guess,
you got.
yeah. I was like, I guess then kind of follow up. This one's a little random, but recently I got to go to the APS March meeting.
Mhm.
And that was pretty cool. And so I kind of want to ask, APS March is like half as large as as the APS Geophysical meeting. That
Mhm.
30,000, that's a lot of people.
Mhm.
How do you go about navigating those types of environments to, I guess, come out on top?
Hmm. It's an interesting way of putting it. I remember I went to March meeting in 2006, 16 or 17. Yeah, I was in New Orleans that year. Um, I think that once you've gone to enough conferences, I don't know what enough really is. I mean, I think about my third or fourth conference, I kind of felt like I knew the drill at that point of like what I want to do. The first one is just kind of really overwhelming, and there's so much stuff happening. I would say that nowadays when I go to conferences, I typically have an agenda. Like they usually will give you like the conference agenda in advance, and so you can kind of look at all the sessions and you can sort of pick, which ones you want to go to and sort of make at least a tentative plan, which sometimes gets changed because you run into an old friend and you want to get coffee or whatever and get lunch, and then your plan gets screwed up. But I would say that at least looking at the conference agenda, and I know it's a little bit different when you're still an undergrad and you don't maybe have like a specialty yet, but when you go to graduate school, especially, you're in a specific area of research. It's typically your advisor's area of research, and so you will be gravitating to kind of all of the talks that are in your little sort of neck of the woods, and usually try and find the people whose names you see all the time in papers. And I think that also messaging people in advance. I think the social media nowadays, it's people are usually pretty friendly of just getting a DM from someone that I've DM'd people of just like, hey, you're going to be at this conference. I'm going to be at there. Do you want to get coffee and discuss, what you're working on and stuff like that? Um, so I'd say that the most to make the most efficient use of your time is to come in with a plan, look at the conference schedule, find the things you find interesting, mark those down, try to go to those, and then make room for, serendipitous meetings with people you find interesting at the same time.
All right. I have one. So I applied to RUs actually, and I got into none of them. So
Okay.
I wanted to hear some advice from you. Like, what would you recommend for people? Like, I guess this could apply to everyone else because I'm aware that some people in here are not just physics. So, what would you say I should do in order to build up, like, let's say, some experience so I could so I have better chances of getting into like a future position?
Yeah, so that's a good question. I would say that if the RUs and the internships don't work out when you apply, I think the next best thing you can do is to just directly cold email professors who work you find interesting at your home institution. It's usually got to be your home institution in that way, and just asking if you can get involved in their lab and say, you're an undergraduate who you're this year, and um, you know explain to them why you want to work with them specifically. So it's usually not a good idea just to email someone like, hey, just give me a research opportunity, please. It's usually better to at least try to read their work. It can be very hard as an undergrad to try and understand like what's this paper saying, but I think if you just are basically volunteering, free work to them, basically. It's um, the only difficulty in that case on their side is that if they have a grad student that can spend the time to at least get you set up, because most of the time, I'm being honest, when you work with a professor, you're actually really working with their grad student. At least that's how it turned out when I was in grad school. People want to work for my advisor, and then it's like, oh, my advisor's like, oh, here's Kyle, and going to work with him. So yeah, I would say directly reaching out to professors whose work you find interesting and proving that you've actually taken the time to try and understand what it is that they do and highlight why you could be an asset to them. And usually a really easy one, as a little secret, is like doing usually undergraduate research, if it's not in the lab and it's more like theoretical or computational work, is like data analysis stuff. So if you know how to program moderately well, that's usually a good selling point for professors if they have an undergrad who can code and do some data analysis for them. Yeah.
All right. I actually have another question. So I actually asked this to like a lot of like other physicists for like advice. This is more like personal for me, but
Mhm.
basically like earlier you mentioned that like with physics, it's not really like what's it called? I forgot the word. I brain farted the word. It was a lucrative,
Lucrative. There you go.
yeah, yeah.
There we go.
So what was it called? So like, I was also at the APS conference as well, and I asked like a couple physicists the same question. Like, um, I grew up since I grew up in like a low income kind of family. Like, money has been a huge aspect for me, but I also love physics a lot.
Mhm.
I chose physics because I felt like it was going to be like a very broad, like I could get into like almost any field with it, right?
Mhm.
Um, and
You
then
can.
I remember I asked like because like I'm really interested in astronomy and stuff like that. I
Mhm.
remember I remember my first year of going into college, I thought like, okay, you know what? Maybe I'll end up with like a lucrative career. I could help my parents, help my family, stuff like that. And then I get responses like, oh, it's not for the money. And then I'm like, oh, so I went into the expectation of like, oh, I could possibly like end up with like a lucrative career, but kind of got boggled down by other people's responses. But I just want to hear like what advice you would give to like someone that does
Yeah.
love physics but is interested in like also ending or interested in ending off with like a lucrative kind of career. So
Yeah, so okay. I think um so it's true that physics is a very broad major and can translate well into other careers. I know physicists who are in finance, I know physicists who are in like med tech, who are doing data science or AI now. Um, and I have physicist friends who are doing, hardcore physics. But I would say that for any job that is not a university physics professor or like a physicist at a national lab or a physicist at an R&D portion of like a company like Google or something, or an astronomer role at like an observatory, outside of those roles, there is definitely an easier path to get to that job. And so my only advice is that if you really do like physics, and I bet people who've done this too, I don't want to like change your whole career, but I've known people who, for example, did astronomy, but they made sure they did like, I don't know, they like someone said their parents would not let them go to college on just like an astronomy major. They had to do like computer engineering too or something. Um, but the thing is that I would say that at the end of the day, a degree is just a piece of paper, and uh, it doesn't really, it really doesn't have to dictate what you choose to study, outside the classroom. And I think that it's definitely like definitely if you want to like I'm gonna be honest, if you want to go have a lucrative career, don't go to grad school because you're sacrificing 5 to 6 years of potential or of income potential there. Where in grad school you have just enough to like survive if you're smart with your money. Um, so that's one thing I noticed when I was in grad school was like, huh, like if I didn't go to grad school, I could have started earning money like, 5 or 6 years sooner than that. And who knows what would have happened. I'm generally very happy I went to grad school, still, despite everything. But I do acknowledge that my current job right now definitely didn't need all that school I did, or I should, there was an easier path to get this job than the way I got it. So,
All right. Also some other like some I guess I forgot my last question, but
mhm.
this is something that I was just thinking about. I just wanted to ask like if you've ever been to the Philippines.
Yeah, I've been there 3 times, most recently in, no, 4 times, but most recently in 2012. So it's been a long time since I've been
Hmm.
back. Yeah.
What was your favorite part, or from like what you could remember? Like, what was your favorite part of like going back?
Favorite part going back. I think, oh, this is hard. Okay, there's like a funny answer and there's like a serious answer. The funny answer is like I remember when I went when I was 9 and we got to stay in this really nice hotel in Manila. It was like, I don't know, 5-star hotel or whatever, and it was just like really fancy. I thought like that was so cool. I also, where did I go? I forgot which beaches we were at. We were mostly in Mindanao, but and that's where most of where my family is from. And so we went to the beach a lot. That was fun. But favorite part too, kind of on a more serious note, was also kind of going back to like my grandmother's hometown or like her. It's kind of, I guess it is a town. I was going to say village, but it's not as small as a village anymore, maybe. But yeah, going into like my grandmother's village, my or town, sorry. My Her dad, my great grandfather, was the mayor of that town many, many years ago. And so it was kind of cool to like go back and see that a lot of people still remembered my great grandfather. And like when my grandmother goes around saying, oh, she's his daughter, a lot of people um comment on, he was a really good mayor and he did a lot of good things for the city. And, I think that especially in a place where corruption is, how do I put it mildly, apparent. I think it's cool to know that there were family members who honestly did good for the people. Yeah.
And I had like a couple more questions, but gosh, it just like faded away in my mind.
I got a lot of time, so if you have more questions, feel free.
Josh Alba asked another question. Going
Mhm.
from physics to data science, what did you find to be the hardest thing to pick up along the way?
Yeah, that's a great question. So I was starting to make the transition in like probably like maybe 3 or 4 months left of grad school. I took one machine learning class in grad school, which helped, but I took it years before I was thinking of leaving, so I mostly forgotten a lot of it. I think the hardest thing to pick up along the way is the just the different kind of tech stack or the tech stack that data scientists are often asked to use. I kind of had it a lot easier coming to NASA because they don't really have a fancy like tech stack where you have all these different like software programs like um I don't know, like Azure or like Node.js or whatever. I think one of the hardest parts is actually the coding, interestingly enough, because scientific computing and programming is way different from like production level quality kind of code that a lot of organizations and companies expect you to know how to write. It's a lot of things you would probably learn as like a software engineer or a computer science major. And so I'm still actually to this day like still wrapping my head around kind of just like basic computer science things. And I I always say actually, I'm glad you asked this because I say if I had time and I look back, I think I would have swapped my math minor for a computer science minor because I think those those kind of core fundamentals you learn in programming and like handling like computer memory and things of that nature, I just didn't have that. So I'm trying to learn it now. It's kind of like trying to learn a new language when you're older. It's just a little bit harder. So that's what I found was difficult.
Oh, okay. I remember my question.
Mhm.
So, if you were to go back to the Philippines, if and specifically with like physics and stuff, what would you do if you were to go back and with the physics degree that you have, like what would you do there? Like would you be willing to have like guest talks at like universities there, or like, um, would you like to make an impact in the Philippines with a physics degree?
Yeah, it's interesting you asked this. Yeah, I would be interested in doing, giving talks if they wanted me to go there and talk. I have had some ideas on how I might want to help, people back home, especially, relatives. Like a lot of my dad's side of the family is here in the United States, but most of my mom's family is still back there. So I still have a lot of, younger relatives and cousins and of the sort. I was thinking a lot about how AI can be used to, help with education in like, countries that don't have really strong educational systems. So one idea I had, and this has nothing really to do with my physics degree, but one idea I did have was that I found this interesting paper of someone who was training large language models on the Bisaya dialect, which is the dialect my family speaks. And I've been trying to ask people who are from there, would it be useful if like you know, educational material was translated into Bisaya or taught in Bisaya. I mean, I don't speak it fluently, and so I don't know if it's at all a useful thing. But in my head, at least, I just thought perhaps it's just easier to learn things in one's own native language than, maybe, even though everyone I know speaks English for the most part, but I just thought it would be good to have, materials, whether it's in physics or in other subjects that can be effectively translated and taught in Bisaya and other dialects like that. Uh,
All right. All right, I'll leave it open now again, to anyone else who has any more questions. I think I'm gonna have like a hard stop at like 6:20. So
okay, 4 minutes.
absolutely. Yeah.
4 minutes, guys. And ask anything.
Uh, I guess sorry, I'm uh one thing one thing I would ask is what kind of how did you manage to take advantage of those opportunities that you were I guess, well, not necessarily given, but how did you navigate resources as an undergrad or
Oh.
as a doctoral student, just in general?
Yeah. I wish I did a better job at that, honestly, looking back. But um I would say, as an undergrad, the reason I found the whole you know, LSAMP or camp program for my first RU was because I saw it advertised on campus, right? I mean, I just saw a flyer and was just like, oh, that's really cool. I think I want to do that. And I'd say the way I go about things nowadays, and kind of it's been true since then, is just show up. And I know that like sounds very basic, but it's interesting how many people don't actually put in the effort to show up to things or like try and be somewhere early or um, I don't know how to describe it. Like I feel like I've gotten really lucky a lot of times and like just by being in the right place at the right time. And it's hard to teach that, I suppose. But I think it's a combination of like being open to as many opportunities as possible that align with your life mission, whatever you define it to be for yourself, and um, knowing a good opportunity when you see it and not letting it slip away. I think a lot of times students often have a good opportunity to network with someone or make a connection with like a professor or are trying or introduced to someone and don't take advantage of that. And I think being brave enough to make the first move and state clearly what it is you're looking for or what you want and see if that person can help you get there is goes a long way, actually.
Any other follow-ups, guys?
I think this should be the last question. Whoever has one. So
Okay, because then if not, I had a follow-up to that. Um, so what do you think is a good what are good ways to develop a good elevator pitch, I guess, because sometimes those situations are kind of instant. Oftentimes you only have a couple sentences
True.
before they lose interest. So
I think the brief answer is like for me, it's have some sort of motto or thing that you really like believe in. Like me, it's to make the world safer and smarter, and I think it aligns well with my job. right? And so come up with some motto or some belief or some thing that you really can do that's broad enough that you feel like you can do it, but also somewhat specific. I don't know. Mine's pretty broad, making the world safer and smarter, right? But and thankfully now all the experiences I've had so far, I think kind of align with that mission. And so even if you don't have like an internship or an opportunity, you can always work on things on your own. I still have a bunch of side projects like my YouTube channel that I think helps with that mission too. And so I think being able to state clearly what it is your mission is that you're trying to set up and do, and having a few examples ready to show how you're working towards that. And that's where a good elevator pitch starts.
All right. All right. I think we're gonna end it off here. So
Okay.
yeah. So thank you everyone for attending. I just noticed that it trickled down a lot. But if you guys haven't signed in yet, please check in right now. But other than that, again, thank you, Dr. Kyle, for speaking for us.
Welcome.
We really appreciate it. I loved hearing a lot about like what's it called? Just like what you do, and also you being Filipino American. I was able to relate on a lot of stuff. So I genuinely
Of course.
appreciate that.
Of course.
So
You're welcome. Okay. Well, thank you for hosting me. And I guess, feel free to reach out on social media if you want to have me back. Be happy to talk again. So
okay.
have a good night, everyone.